All our students. So in this video, we're going to be talking about area. Yesterday, we learned a little bit about perimeter, which, to remind you, perimeter is the distance around the outside of an object. And if you remember, I asked you to start thinking about perimeter and area in two different spots in your head. Of any shape, you can measure the perimeter of it and you can measure the area of it. So it's not a matter of the shape telling you whether to use area or perimeter, but rather it's a matter of what your task is. And in real life, that's what dictates, that's what makes you choose whether you're going to measure perimeter or whether you're going to measure area. Now, where perimeter measures the space around something, area actually measures the amount of space. So if you look up here, I've got a dude from the 90s that he is laying down a carpet pad that he's going to put carpet on top of. Now, for him to lay carpet, he did not need the perimeter of the room. He needed the dimensions of the room, but he didn't calculate perimeter to lay down the carpet. Now, there were little tack strips that you lay around the perimeter to keep the carpet down. And for that, he did use perimeter, but for the actual carpet, he needed the area. He needed to measure this whole space so that when he went to the carpet store to buy carpet, he knew that he had enough carpet to lay it down over the whole space. So if you're building things, area is a super common measurement to use. So measuring carpet would be one. Measuring wall space. So if you've done any sheetrocking in your house where you lay up sheetrock over the studs and then paint over it, that's going to take area because sheetrocks come in certain size sheets. I think it's 4x8, and so if you're going to sheetrock a whole wall, you've got to measure out the sheetrock and cut it exactly so that you're not buying too much sheetrock, but not too little, but just right. And same thing with painting. We've painted like so many rooms in our house since we bought it, and we've had to buy our paint. We've bought the amount of paint that we needed based on the amount of square space that our walls were. Any wood projects, so if you're laying flooring down, decks. I have a little bridge thing in my backyard that's like 25 years old and it's rotting out. And so I'm going to have to rebuild that sometime soon. I was actually measuring it over the weekend, and I had to measure, part of it was the area that I needed to measure to make sure I was going to buy enough wood to make the bridge work. Anything, so when you're going, if any of you have bought a house recently, or if you're looking into buying a house, if you're a major factor in how much a house costs is how much square footage the house costs. So houses that have more square footage or that are bigger are going to cost more than houses that have less square footage, because those houses are smaller, because the square footage is the area, is how much that it uses to measure. So there's lots of different ways to use area. Measuring gardens is another common one that if you've got an area that's set out to be your garden, you need to know how much seeds you can plant in there. And so one way you can do that is by calculating area. So what kind of strips students' gears just a little bit when they're thinking about area is that it's measured in square units. So a square unit is a square that is 1 unit long and 1 unit wide. And if you think about, like this guy laying carpet, you can't just measure in a straight lines to figure out how much carpet you would need to lay down. You kind of have to think of it as laying down little squares one after another to find the area. So let's think about this. So let's say this room's a little oblong shaped because he's got this fireplace here, but he's laying carpet in these 3 rooms. And so he's got to figure out how much carpet he's going to need. And they're just giving it to us in units. They didn't say whether it's inches or feet or whatever. But let's do this chart together. So this column has the pictures. This one's going to have the base, which is the measurement across the bottom. This column has the height, which is the measurement across the top. And then this one has the area, or how many total square units there are. So if I take a look at this one, they already filled in the base for me. The base is 5 units, and I can count that by going 1, 2, 3, 4, 5. The height, I can calculate that by just counting how many square units up is it. So 1, 2, and 3. So the height on that one is 3 units. I might as well make that a little bit bigger. So that means the area here, let's count up the areas, how many total units there are. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So that picture has 15 total units. So the area of that would be 15 square units. And we can call it 15 units squared. We can do 15 square units. Either one works. I'm just going to do square units for this one, and then we'll do the units, the units squared on the next slide. So this next one, the base, remember, is the number across the bottom. 1, 2, 3, 4, 5, 6, 7, 8. So it's 8 units across the bottom. And then this next one, the height is 2 units tall. And I measured that just by counting that there's 1 tall and then 2 tall. So that means the area here is, there's 2 ways I can do it. I could count it up just like I did on the last one. I can also notice that I can think of these columns as groups. So that means because there's 8 across, there's 8 groups, 1, 2, 3, 4, 5, 6, 7, 8. There's 8 groups of 2. So one way to actually think about area is to think about area as being the base times the height. You can multiply the bottom number or the top number times one of the side numbers to calculate how many square units it is. So in this one where I could count them all individually, or I could say 8 across the bottom times 2 on the side equals 16 square units. Not unites, units. I'll make that a little bit bigger too. And we'll move it up so it's in its own box. There we go. And this last one, the base is 1, 2, 3. So 3 units. And then I can count the height also as 1, 2, 3 units. So that means the area, I could count up all of those individual squares one by one. Or I could say this is kind of like having 3 groups of 3, right? There's one group of 3 in one column, another group of 3 in another column, and another group of 3 in another column. So that would be, the total would be 9 square units. If I was to think of that, either count up the units one by one or multiply the base times the height, the bottom number of 3 times the side number of 3. So the relationship here is that if I want to find the area, I can calculate the number of units along the bottom times the number of units on the side, or it can be the top times the side, either way. Just bottom or top times one side or the other side, and if it's a square or a rectangle, that will get you the correct answer. So let's look at a few examples. So in this picture, I can see that it is 2 inches would be my height, and then 7 inches is my base. Now remember, typically we kind of like the base to be the bottom number, but it really doesn't matter. It can be this top number. You're just going to multiply one side times the side that's perpendicular to it. So remember, we can think of area as equaling base times height. So with this one, I had a 7 inches was my base, and I can multiply that times 2, and that's going to equal 14. And remember, it's inches, right? Those sides are inches, but I'm turning that into, let's see if this will work. Oops, I did times 1. I multiplied the lengths of the sides, right? But really by doing that, it turns it into a grid. Oh, it didn't really want to do that. That's okay. But you could think of it as the 7, each one going down, 1, 2, 3, 4, 5, 6, 7, and then 2 across. So it's not 14 inches. Whenever we're measuring area, it has to be in square units or units squared. So I could say that it is 14 square inches would be one way. I could also type it as 14 IN, and then IN is inches, and then you can do a squared, which is a little 2 next to the inches, because it's an exponent, which you guys will learn about later. But either way is acceptable. You can say 14 square inches, or another way to do it would be SQ. You can abbreviate it SQIN. Those are abbreviations, or you can do 14 inches. And that little 2 means that they're square, that each has 14 square inches on there of 1 by 1. So that's one way of doing it. This next one is 9 meters times 9 meters. And even though this one is kind of diagonal, like if we go back and look at this original picture, even if it's diagonal, it's still the same picture fundamentally. So in this one, if we're thinking of area as base times height, which we should, that is what area is. Sorry, talking and thinking is hard at the same time while teaching. So with this one, 9 by 9 is the area equals the base times the height. So to find that, I would do 9 is the base times 9 is the height. And together, remember, I'm multiplying. Some students will forget and they will add, but 9 times 9 equals 81. And I can write that as square meters, like that, or I can write it as 81 meters. And I'll just copy that the superscript 2, 81 meters squared. This is saying the same thing, but this is very important to have that part on there. And this last one, my base here is 8 times 14. And I could do 8 times 14 is, what's that, 112? I know that 8 times 12 is 96. So then another 8 would be 104, and then another 8 would be 112. So that one would be 8 times 14 equals 112 square feet. Or again, you could also do 81 feet squared. Let me turn off my alarm. So those are ways to measure perimeter. The main thing is that you're multiplying the base times the width, and that you have to remember to have your units in square units. Thank you so much for watching. Our next lesson, we're going to be talking about problem solving for area or different story problems that we can use to figure out the area of things. And I'll provide a little personal story example with that. So thanks so much for watching, and good luck on your math today.